number system, its basic fundamentals, some basic points before solving numerical problems related to number system. We must aware some numbers. You have already studied in previous classes some numbers. Now let us revise. Natural numbers. Natural numbers. All counting numbers are said to be natural numbers. All counting numbers are said to be natural numbers. For example, 1, 2, 3 and so on are natural numbers. Now, the smallest natural number is 1. The smallest natural number is 1 and largest natural number is not defined. It is the collection of natural number is denoted by capital N. We use capital letter N to denote the set of natural numbers. Now second one is whole numbers. Whole numbers. All natural numbers, all natural numbers including with 0 are called whole numbers. For example, 0, 1, 2, 3 and so on. Here the smallest whole number is 0 and largest whole number is not defined, and the collection of whole number is denoted by W. Collection of whole number is denoted by W. Now the next number is integers. Integers. All natural numbers, all natural numbers 0 and negative of natural numbers are called integers. All natural numbers 0 and negative of natural numbers are called integers. For example, -3, -2, -1, 0, 1, 2, 3 and so on. Here again to this side to minus infinity. Now this set is negative integer and set from 1 to this to infinite is positive integer. Now 0 is neither positive nor negative. Now if you want to represent it on number line, then take it as 0, 1, 2, 3, and so on. Similarly, here it is -1, -2, -3, and so on. So this is the representation of integers. Now the collection of integers is denoted by Z. The collection of integer is denoted by Z. So what we can say? All natural numbers are whole numbers. All natural numbers are integers. All whole numbers are integers. But all integers are not natural number, or all integers are not whole numbers. Now the next one is fractional number. Fractional numbers. A number which is written in the form of P by Q, where P and Q are natural numbers, is called fractional numbers, and it is denoted by this symbol P by Q, A by B. Some examples: 1 by 2, 3 by 2, 5 by 7, 9 by 4, etc. Fractional number is again divided into parts: proper and improper. Proper, in case of proper, numerator is less than denominator. If numerator is less than denominator, it is called proper fraction, and improper, if numerator is greater than or equal to denominator, it is called improper fraction. Now the next number is rational number. Next number is rational number. Rational numbers. A number which is written in the form of a number which is written in the form of P by Q, where P and Q are integers and Q cannot be 0. Now here you can see there is a little bit difference between these two. Here P and Q are natural numbers, and here P and Q are integers. So it may be 0. So the condition is denominator cannot be 0, Q cannot be 0. For example, 2 by 3, 0. 0 is also a rational number because it can be written as 0 by 1, 0 by 2, whatever you can write. Minus 3 by 4, these all are rational numbers. Now it is the set of rational number. The set of rational number is denoted by Q. The set of rational number is denoted by Q. Now we'll take some examples. Other examples: 22 by 7. This is a rational number. 5 by 11. These are, even 2 is a rational number because it can be written as 2 by 1. So these are the rational numbers. So now the next number is prime numbers. Prime numbers. A number A number is called prime number if it has exactly two factors. It has exactly two factors. For example, 2, 3, 5 and so on. Now let us see to understand this 2. 2 has factors 1 and 2. 2 has only two factors. One is 1 and other is 2. Similarly, 5 has factors 1 and 5. So it has exactly two factors. So that's why it is called prime numbers. The smallest prime number is 2, which is also the smallest even prime. This is the smallest as well as it is the smallest even prime number. Now the next number is composite numbers. Composite numbers. A number is called composite number if it has more than two factors. More than two factors. For example, 4, 6, 8, 10, etc. 4, 6, 8, etc. Now let us see why these are composite numbers. Since 4 has factors 1, 2 and 4. It has three factors. So now it has definition, by the definition it has more than two factors. Then it is said to be composite number. Now 6 has factors 1, 2, 3 and 6. So it has four factors. So it is more than 2. So now this is composite numbers. Next number is co-prime. Co-prime. Two numbers are said to be co-prime if it has one as common factor. Two numbers are said to be co-prime if it has one as a common factor. That means we can say that if there are two numbers A and B, if SCF of A and B is 1, that means it is always co-prime. Implies that you can also say that there is no common factor other than 1. They are said to be co-prime numbers. For example, 3 and 4, these two numbers are co-prime numbers. And between 3 and 4 there is only 1 as a common factor. 5, 7 are co-prime numbers. Co-prime, it doesn't mean that these two numbers must be prime. 3 and 4, 3 is a prime number, but 4 is a composite number. Now 3 and 4 are said to be co-prime. Now the next point is now decimal representation of rational numbers. Here two terms are very important. First is terminating. First is terminating. That means it ends after some finite digit. For example, 1 by 2, 0.5. It ends after one digit. 1 by 8, that is 0.125. It ends after 3 digits. Now second point is non-terminating, repeating decimals. A number which repeats after a digit, which repeats number which repeats after a digit or a set of digits is called non-terminating repeating decimals. For example, we can say 2 by 3, 2 by 3, that is points. If you divide, what will get 0.666 and so on. So what we can write it as 0.6 bar. Similarly, 3 by 11. If you divide 3 by 11, you will get 0.2727 and so on. So what we can write 0.27 bar. Repetition of 2 digits. Now in case of terminating, denominator, it terminates. If denominator is of the form, one form you can say, if P by Q is a number, then Q must be in the form of 2 raised to power m and 5 raised to power n. If that means you can say, if in denominator it has 2 and 5 as a factor, it always terminates, where m and n are integers. Where m and n are integers. Now let us see some examples of rational numbers in decimal form. 0.2. 0.2 is a rational number. 0.45, 0.7 bar. These all are examples of rational numbers. Now the next point, how we can insert rational number between any two given rational number. Now rational numbers between two given rational numbers. Let us see some examples to understand this rational number between two given rational number. For example, suppose you have to insert 4 rational numbers between 3 by 4 and 2 by 3. 2 by 3. Now we have to insert 4 rational numbers between 3 by 4 and 2 by 3. So what we can write, 3 by 4 and the next one is 2 by 3. Now convert it into equal denominator. Convert it into equal denominator. Now their LCM, you can see their LCM is 10. Their LCM is 10. So what we can write, it can be converted into 4, 3, 3 3s are 9 and 3, 4, 4 3s are 8. So this is 9 by 12 and second one is 8 by 12. So 3 by 4 we can write it as 9 by 12 and this as 8 by 12. Now we have to insert 4 rational numbers. So multiply at least one more than this 4, that is multiplied by 5 in numerator and denominator to convert into equal denominator. Now here it is 60 and here it is 60. Now after multiplication 45 and here it is 40. So therefore this 3 by 4 can be written as 45 by 60. 2 by 3 can be written as 40 by 60. Here we can multiply these 2 by more than 5, that is 6, 7, 8, 10 up to 10. Whatever you want, you can do the multiplication and you will get a lot of rational numbers. So here now we have 40 by 60 and second one is 45 by 60. So 4 rational numbers between 2 by 3 and 3 by 4 are 41 by 60, 42 by 60, 43 by 60, 44 by 60. Take another example to find out this. Now take example in the form of decimals. Next example is find 4 rational number between 3.4 and 3.5. So now you have to insert 4 rational numbers between 3.4 and 3.5. So no need to convert it into in the form of P by Q. Here we can use the decimal representation of rational numbers. So directly we can find out the answer. 4 rational numbers are 3.4 and 3.5. So what we can write 3.4, we can write it as 3.40 and 3.5 we can write it as 3.50. Now there is a gap between this 0.40 and 0.50. So we can write 2 rational numbers. So 4 rational numbers are 4 rational numbers between 3.4 and 3.5 are 3.41, 3.42, 3.43, 3.48, etc. So you can find out rational number between any 2 given rational numbers by using this method also and by using this method also. Here in this case we have to convert this given number, rational number, into equal denominators and then we multiply, and after that we have to enlarge it, we have to convert it to equivalent fractions. Then we can insert different rational number between given rational numbers. But here we can find out the direct result. Now the next number is irrational numbers. Irrational number. A number which is non-terminating and non-repeating decimals is called an irrational number. In case of irrational number, it is non-terminating. The first point is non-terminating. It never ends up to finite number. and this is non-repeating decimals. So it is non-terminating as well as non-repeating decimals. So such type of numbers is called irrational numbers. For example, under root 2, under root 3, cube root 7, root 8, 9 root 11. These all are irrational numbers. Now, the next example again, pi. Pi is again an irrational number. While as we read the value of pi as 22/7, but this is not exactly same. If 22/7 is there, so 22/7 is a rational number, but pi is an irrational number. So pi is an irrational number. Now next example, 1.01, 001, 0001, and so on. So this is non-terminating and non-repeating, no repetition. So it is non-terminating and non-repeating decimals. So that's why it is called irrational number. Now let us try to understand rational between. Now we have 4 points that to discuss. First, rational numbers. Rational numbers between two given rational numbers. Irrational numbers between rational numbers. Rational numbers between two given irrational number, and irrational numbers between two given irrational numbers. Rational numbers, you have to find out some 3 rational numbers, 4 rational numbers between any two given rational numbers. Similarly, irrational numbers, 3, 4, 5 rational numbers we have to find out between any two given rational numbers. Now next, rational numbers between two given irrational numbers, we have to find out rational numbers. And last one is irrational numbers between any two given irrational numbers one by one. Now let us see some examples to understand these 4. Now this is first case, second case, third case, fourth case. Now example. First, find 5 rational numbers between 3/4 and 4/5. So here there are 2 methods. The first method, we will convert it into equal denominator. Then we can find out 5 rational numbers between these two given rational numbers. Now there is one more method, solution. 3/4. 3/4, what we can write it as 0.75, and 4/5, that is 0.8. So between 0.75 and 0.8 there are infinite rational numbers. So we have to write only 5. So 5 rational numbers, 5 rational numbers between 3/4 and 4/5 are 0.76, 0.761, 0.762, 0.77, and so on. So we can write so many numbers, 0.78. So these are rational numbers. You can write some different rational numbers between these two given rational numbers. Now example 2. To understand irrational numbers between two given rational numbers. Now let us consider the same example. We have to find five irrational numbers between 3 by 4 and 4 by 5. Find five irrational numbers between 3 by 4 and 4 by 5. So 3 by 4 is written here 0.75 and 4 by 5 is 0.8, or you can write it as 80. So now we have to insert five irrational numbers between this 0.75 and 0.80. So this can be written as five irrational numbers are 0.760, 7600, 76000, and so on. So this is the first number. Similarly, we can write another number 761 2 761 762 777, and so on. This is second number. Next, we can write 761 7611 76111, and so on. Next, take another point, 0.77 7766 77666, and so on. 0.774 744 7444, and so on. One more number, 0.775 7755 77555, and so on. So we can insert infinite number of irrational numbers between 0.75 and 0.80. Now let us see third example. That is, now third example, rational numbers between irrational numbers. Now consider an example. Find four rational numbers between 0.20 to 00 to 000, and so on, and 0.23 1 311 311, and so on. These two irrational numbers are given there, and we have to find four rational numbers between these two. So now compare the digits. This is 20 and 23. So we can insert four rational numbers are between these two. This is 202. We can also extend it up to how much digit we want to take. So this is 20. Either you can use 20, 22, 23, or 202, 231. There is a lot of decimal points, so we can write it as 231, 202, 207, 208, 209, 0.21. So these are four rational numbers between these two irrational numbers. Now the last example, that is example number 4. We have to insert irrational numbers between two given irrational numbers. Now consider the same example. Find three irrational numbers between point 210, 2100, 21000 and so on, and point 241, 2411, 24111 and so on. We have to find out three irrational numbers between these two given irrational numbers. So we can write directly, this is 210 and 241, so we can insert infinite irrational numbers. Now we have to insert only three irrational numbers. So three irrational numbers are 0.227, 227, 227 and so on. This is the first 0.220, 20, 200, 200 and so on. 0.225, 225, 225 and so on. So we can insert infinite irrational number between any two given irrational numbers. Now that is at last we'll get some basic results. So these are some important points. Number one, we can insert there are infinite rational numbers between any two given rational or irrational numbers. There are an infinite rational numbers between any two given rational or irrational numbers. Now second point, there are infinite irrational numbers between any two given rational or irrational numbers. So we also have infinite irrational numbers between any two given irrational numbers. So these are some fundamental basics related to number system. Now in next video we have to discuss real numbers and its representation. So thank you.